Hello, today I will be explaining how I determine the limiting reagent of the reaction between sodium bicarbonate and copper sulfate pentahydrate and the percentage yield for the precipitate. Here we can already see the balanced equation for the reaction, and on the sign we have an N for moles, and small m for mass, and a big M for molar mass. We also already saw with two known masses for the reactions, which is 1.5 grams for both. Firstly, we must calculate molar mass of both reactants. To find the molar mass, you must add the relative atomic masses of each element of the compound. It is important to know that you multiply by the subscript, but not by the coefficient. By doing this, we can see that the molecular mass for sodium bicarbonate is 84.01 grams per mole, and that the molar mass for copper sulfate is 177.64 grams per mole. Now that we have the masses and the molar mass for the reactants, we can calculate the moles of our reactants. To do this, we use the equation moles equals mass over molar mass. Thus, moles for sodium bicarbonate is 0.01786, and the moles for copper sulfate pentahydrate is 0.00844. Now we can determine which reactant will be the limiting reagent. To do this, we divide the moles of the reactant by its coefficient from the balanced equation. The limited reagent will have the smallest number. Therefore, we can see that 0.00844 is smaller than 0.00893, showing that limiting reagent is copper sulfate pentahydrate. Now we can transfer the mole of copper sulfate pentahydrate as the mole of our precipitate, which is copper carbonate. Due to the mole ratio between copper sulfate pentahydrate and copper carbonate is 1:1, the moles remain the same. Now, because we want to find the mass, we first need to find the molar mass of the precipitate. Again, to do this, we need to add the relative atomic masses for copper carbonate. This gives us a molar mass of 123.56 grams per mole. From this, we can calculate the theoretical mass of the precipitate because mass equals more times molar mass. This calculation gives us theoretical mass of 0.143 grams. Additionally, these calculations can be repeated for the other products as seen on the paper. To find the percentage yield, we divide the experimental mass by theoretical mass and multiply it all by 100. Please note that the experimental mass was recorded from the experiment that we conducted. This gives us a percentage yield of 94.89%. Thus, we have a high yield of the precipitate. Thank you for watching.